this video, we are going to dive more into Venn diagram. Venn diagram is a representation of sets in closed figures like rectangle, circles, squares, triangles, and other quadrilaterals and other shapes. In solving Venn diagram questions, four things must be checked. One is the intersection of the sets. 2. The union of the sets. 3. The complement of sets. And 4. Disjoint sets. These above listed points are about to be explained in this video. But note that in this video, the video is directly for 2 sets problem, not 3 sets problem. In 2 sets problem, sets are represented in especially 2 circles and a rectangle. So there are 4 regions in a Venn diagram, which represent a 2 sets problem. So this is the question to be solved. Suppose we have 2 sets A and B. A equals 1, 2, B equals 2, 3, and U equals 1, 2, 3. Represent this information on the Venn diagram. But note that the U in Venn diagram questions means union. Union refers to a term used for all the sets under discussion or the sets that are being talked about. So in the question above, the union refers to the A and B, talking about the A and B. Also, before representing an information on a Venn diagram, you must first write your given information. The given information is a way of summarizing the question given to you. This is an example of how given information is written in a 2 sets problem question. So this is the given information for the question previously written. So let the number of the n means number and the bracket means of. So let the number of u, which is the union, equal to 1, 2, 3, 4. Number of A equals 1, 2. Number of B equals 3. And number of A intersection B. Number of A intersection B is an empty set. And number of A union B complement equals 3. Sometimes you can be given percentage question. Your question may be percentage wise. So let the number of union be 100%, number of F be 45, number of T equals 34. So every question has its way of writing this given information. Some questions have decimals, others have whole numbers, others also have percentages. So every question has its own way of writing its given information. So let's start with the intersection of sets. This refers to a region or part or members where 2 sets share simultaneously. So the numbers or the members where A and B share simultaneously, which means at the same time, refers to the intersection of the sets. It is represented with the lowercase alphabet n. For example, A intersection B is said A intersection B, which means the regions or members where set A and set B share at the same time. For example, when you are being given that A equals 1, 2, 3, 4, 5, 6, 7 and B equals 2, 4, 6, find A intersection B. The answer will be the numbers or the members of those 2 sets which appears in A and at the same time appears in B. So 1 appears in A but does not appear in B. 2 appears in A and appears also in B. So our first number will be 2. Let's move on to 3. 3 appears in A but does not appear in B. 4 appears in A and also appears in B. So now we have 2 and 4. 5 appears in A but does not appear in B. 6 appears also in A and at the same time B. So we have 2, 4 and 6. And 7 appears in A but does not appear in B. So the answer to this question, A intersection B, is A intersection B equals 2, 4, 6. Always when you are writing the elements of a set, put them in curly brackets. So the answer is 2, 4, 6 because both sets A and B share numbers 2, 4, 6. So now let's look at how intersection of sets is represented on a Venn diagram. The intersection of the two sets A and B is where it has been shaded red. So study the color codes in this video. They may prevail in it. The picture on the right indicates the regions in two sets problem. So this picture, it represents the regions in two sets problem. So the number 1 refers to the intersection part. The number 2 refers to the only part. 3 refers to also the only part, and 4 refers to the neither or the region 4. So we have 4 regions here: region 1, region 2, region 3, and region 4. So let's come to the intersection. So where there is the red hatching is the A intersection B. So this is number of A, number of B. So where these two circles share simultaneously is where the red hatchings are. So region 1 is A intersection B. So let's talk about the union of sets. Union of sets refers to the summation of all the sets under discussion. That's region 2, region 1, region 3, and region 4, if any. Union is represented by U. The union is represented by U and is written as number of U at the top right corner of every Venn diagram question, but is outside the boundaries of the rectangle, as in the following diagrams. But note the color codes which were used for the shading of the regions. Region 1 is the red color, region 2 is the yellow color, region 3 is the purple color, and region 4 is the green color. So the union of sets, this is how they are represented. So the only part, so region 2, region 1, which is the red, and region 3, which is the purple color. When you sum all these regions, they equate to the union. So sometimes you may not be given region 4. So region 2 plus region 1 plus region 3 equals number of union. Sometimes you may be given also the region 4. So region 2, which is the yellow part, region 1, which is the red part, region 3, which is the purple part, and region 4, which is the green part. When you sum all these parts up, it equates to the number of U. So this explains that, or this tells us that the sets under discussion refers to the union, like what we said already. Let's start with the complement of sets. The complement of a set is referred to as the members of the union set or the numbers in the union set which cannot be found in the set you are being asked of. So, for example, if U equals 1, 2, 3, 4, 5, 7, the U means union. So, if union equals 1, 2, 3, 4, 5, 6, 7, Q equals 2, 4, 6, and you are asked to find the complement of set Q. The question is demanding you to write the numbers in the union set which are not in the set Q. So Q complement is equal to the numbers in the union set minus the numbers of set Q. So this means just a simple trick is just take these numbers in set Q, 2, 4, 6, exclude them from the union set, and the answer numbers remain is the complement. So if U equals 1, 2, 3, 4, 5, 6, 7, Q equals 2, 4, 6. Let's begin with the solution. So 1 is in set U, but it cannot be found in set Q. So 1 qualifies for the complement of set Q. 2 is in set U and is also in set Q. So 2 does not qualify. 3 is in set U but is not in set Q. So we now have two numbers as our complement, 1 and 3. 4 is in set U but is not in set Q. So 4 does not also qualify. 5 is in set U but it's not in set Q. So 5 qualifies. So we now have three numbers, 1, 3, and 5. 6 is in set U but is also in set Q. This does not qualify for complement. And the last number 7 is in the union set but is not in set Q. So 7 also qualifies for the complement of set Q. So we now have our answer to be Q complement equals 1, 3, 5, 7. So note that when you deduct or when you exclude the members of the set Q from the members of set U, so take 2, 4, 6 out of set U, it will be remaining with 1, 3, 5, and 7. So that's how complement of sets is solved. So note that the complement of a set is denoted by attaching an apostrophe to that set. Like when you were asked to find the complement of set Q, when you want to denote it, when you want to write it as a symbol, you write Q and bring an apostrophe sign in front of it. So the complement of a set is denoted by attaching an apostrophe to that set. So let's say the complement of set S is written as S apostrophe. You see, so the complement of set A will also be written as A apostrophe. The complement of set B will also be written as B apostrophe. The complement of D will also be written as D apostrophe. So to write a complement of a set, attach an apostrophe sign to that set. So the complement of S is written as S apostrophe. So at your leisure time, solve this question and post your answer on the comment review of this channel. So let's look at this question. If U equals odd numbers between 1 and 16 and J equals prime numbers from 1 to 15, find J complement. If U equals odd numbers between 1 and 16 and J equals prime numbers from 1 to 15, find J complement. This question is easy to be solved, but I want you to solve it at your leisure time. Now let's come to disjoint sets. Disjoint sets, as is in its name, disjoint means they are not joined. So these are sets without no intersection. So disjoint sets do not have any region which they share simultaneously, like the intersection. So we can say that The opposite of intersection sets is the disjoint. So they are represented on Venn diagrams like number of A, the circle of this, the circle of B. You see they have no intersection, or they have no region where they share simultaneously. They are separated. So this type of set is called the disjoint set. So they are sets without no intersection. Now let us apply the four things which we have learned on Venn diagram. That is the intersection of the sets, the union of sets, the complement of sets, and disjoint sets. But let's review on the color codes once more. The red in this video is standing for region 1. The yellow is region 2. Purple is region 3. And the green color is region 4. I'm taking it again. The red is region 1, the yellow is for region 2, the purple is for the region 3, and the green is for the region 4. So kindly pay attention to these. They are applied when representing information on the Venn diagram. So number 1, the number of A equals region 2 plus region 1, where region 1 is the intersection of the two sets. So region 1 has the color code red and region 2 has the color code yellow. So when you sum up region 2 and region 1, as in this diagram, region 2 plus region 1 will give you number of A, and number of B equals region 1 plus region 3, where region 1 is in the intersection of the two sets. Region 1 has the color code red and region 3 has the color code purple. So summing the 1 and the 3, or the red and the purple up, will give you the number of B. Number 3, the number of A intersection B is the region 1. This is where the red hatching is. So number of A intersection B, where set A and set B share, is the red color, or where the red hatching is. Number 4, the number of A union B is equal to region 2 plus region 1 plus region 3. Sometimes the union may be given in two different ways, where the region 4 is given and where the region 4 is not given. So let's look at the number 5 trick. So this is where the region 4 is given. So region A union B equals region 2 plus region 1 plus region 3 plus region 4. The number 5 is applied when region 4 is in the question, but the number 4 is when the region 4 is not in the question. So let's look at this diagram. So let's take the number 4. Number of A union B equals region 2 plus region 1 plus region 3. So region 2 is the yellow color, region 1 is the red color, and region 3 is the purple color. So when you sum all these up, it refers to the number of A union B. The number of A union B sometimes may mean the union, but sometimes they are not referred to as the union. Also, the number of A union B, which is region 2 plus 1 plus region 3 plus region 4. Let's notice in this diagram below. So region 2, which is the yellow, region 1, which is the red, region 3, which is the purple, and region 4, which is the green color. This also gives the number of A union B. So the A union B can be given in two ways. The one in which the region 4 is there, and the one in which the region 4 is not given. So let's look at the trick number 6. Number of A intersection B complement equals region 2 or region A only. So you can write A intersection B complement or A only. This is where the yellow hatching was. And let's look at the trick number 7. Number of A complement intersection B. Number of A complement intersection B. This is the region 3 or B only. So you can write number of A complement intersection B or number of B only. Let's look at them in the diagram. So let's take the trick 6. Number of A intersection B complement is the region 2 or where the yellow hatching is. So look at where the yellow hatching is. Note that the intersection was not shaded. So where the yellow hatching ends is the region 2 or region A intersection B complement or region A only. But when you sum the A only and the intersection, it will give you the number of A. Summing A only and the intersection will give you the number of A. So region 2 is where the yellow hatching is. And let's come to the trick 7. Number of A complement intersection B equals region 3 or B only. So where the purple hatching is the region 3 or region A complement intersection B. So where the purple hatching ends is the B only. So when we are asked to find uh, an a complement set intersection, a non-complement set like A complement intersection B, just take the set with the complement out. Take the set which has the circle of the complement out. So let's say A complement intersection B. It means take A out. So take the circle of set A out. So when you take the circle of set A out, you know that you will remaining with only the region 3, which is the B only. And also A intersection B complement means take the circle of set B out. So when you take the circle of set B out, you'll be remaining with only region A only. So let's look at the trick 7. Number of A union B complement equals region 4. Number of A union B complement equals region 4. So region 4 is the region where is shaded green, or the region in the rectangle when you exclude the two circles. So number of A union B complement, like the trick I told you in the tricks 5 and 6. So let's take A union B out and you will get the A union B complement. So A union B is the region 2, the region 1, which is the intersection, and the region 3 or B only. So when you take that A union B out, you'll be remaining with the region 4 or the region A union B complement. Trick 8. Number of A intersection B complement equals region A union B minus region A intersection B. So region A intersection B complement. Note that the complement comes outside the brackets. It depends on where the apostrophe sign is. So each position of where the apostrophe sign is placed has its meaning. So here it has been placed outside the bracket. So number of A intersection B bracket close complement equals number of A union B minus number of A intersection B. So this means when you take A intersection B out, the region left equals A intersection B complement. So A intersection B is the intersection. So when you take the A intersection B out from the whole diagram, you are left with number of A intersection B complement. So here are other simple things to adhere to before we continue, and they are mostly applicable when using the Venn diagram. Number one, when you are asked a question like find number of A intersection B complement. Here the complement is put in front of the set B. So let's look at how to solve it. So just take out or exclude the circle of the set which has the complement sign. So A number of A intersection B complement, how to solve it, it says that take out the circle of the set which has the complement sign. So in this question, the circle of the set which has the complement sign is set B. So it means take the circle of set B out and you'll be remaining with number of A intersection B complement, or A only, which is the region 2 or where it was shaded yellow. Number 2, when you are asked a question like find N intersection A complement intersection B, this applies to, this is the same as the number 1 trick. So A complement intersection B means take the circle of the set A out and you'll be remaining with set B. So to solve it, just take out or exclude the circle of the set which has the complement sign, which is set A in this question. So A complement intersection B, just take the circle of set A out or the circle with the apostrophe sign attached to it, and your answer will be B only or region 2 or where it was shaded purple. Number 3, when you are asked a question like find number of A union B complements, here just take out, note that the complement sign came after the brackets or the parenthesis sign. So to solve it, exclude the two circles since number of A union B is the union of the two circles. So when you have A union B, we are come to find A union B complement. So when you have A union B and you take out the A union B, which is the region 2, region 1, and region 3. Note that here region 4 was included. So let's take the two circles out, the region 2, region 1, and region 3. So when you take them out, you'll be remaining with this. So the part shaded green is the number of A union B complements. So when you take out the region 2, region 1, and region 3 from this whole diagram, you'll get this as your answer. So region 4 or where it has been shaded green, or the number of A union B all complements. Also, let's look at the De Morgan's law. The De Morgan's law is found in mostly set questions. De Morgan was one of the greatest mathematicians in the world. So his law stated that number of A union B all complemented equals number of A complement intersection B complement. So number of A union B complement equals number of A complement intersection B complement. Number two, number of A intersection B or complement equals number of A complement union B complement. Also, when you see a statement such as each student plays at least one of the two games, each student reads at least one of the books, each student studies at least one of the subjects in a Venn diagram question, it means region 4 is equal to 0, or region 4 has none, or region 4 has no members. So when you see each student plays, each student reads, each student studies at least, so the at least means region 4 is equal to 0 automatically. So in any Venn diagram, draw your Venn diagram if the question did not ask you to do so. So when you are given a Venn diagram question, draw your Venn diagram even if the question did not tell you to do so. So in any Venn diagram question, you will notice that before you start solving, the union is less than the summation of all the sets. The question is not wrong until you solve it. So it's just a trick. So in any Venn diagram question, you notice that the union or the number of few is lesser than the number of the summation of all the sets. Let's begin with our first question. So in a class of 40 students, 30 read mathematics, 20 read English. Each student reads at least one subject. How many students read both math and science and English? Sorry. So as step one is write your given information. So when you are given a Venn diagram question or a two-stage problem question, your first step is that write the title, given information, and underline, and write the clues in the question. So like this, write given information and neatly underline it. So let's start. So you write let number of u, which is the number of union or the total, be equal to the number of students in the class. So the number of students in the class equals the u. So there are 40 students in the class. So number of u will be equal to 40. Now let's come to the second clue. Number of m, where m represents mathematics. So number of m equals the number of students who read mathematics, and there are 30 students who read math. So the number of m will be equal to 30. Let's come to the third clue. 20 read English. So number of e, where e represents English, refers to the number of students who read English, and there are 20 students who read English. And note that it is now left with region 1, which is the number of M intersection E, or both maths and English. So we were asked to solve the both maths and English. So you represent it with any variable you like. So let's say we represent it with the letter T. So number of M intersection E equals the students who read both maths and English. So we are about to solve it. So number of M intersection E equals T. So we've represented it with the variable T. Then let's come to our step 2. The step 2 is illustrate the given information on a Venn diagram, but write the title Venn diagram and neatly underline. So you write Venn diagram and neatly underline it before you continue. But note, where we have the 30 minus t is the region 2 or M only, or N intersection E. And where we have the variable t is the intersection or the number of M intersection E. Also, where we have the 20 minus t is the region 3 or E only. Region M only equals region M minus region N bracket open M intersection E. So number of M only or number of mathematics only equals the total number of mathematics minus the number of intersection, and the number of E only equals the number of English minus the number of the intersection of the two sets. So let's apply it here. So where we have the 30 minus t, so here the region 2, so 30 minus t, and where we have the variable t is the intersection. So where t is the intersection of the number of M intersection E. So M intersection E was represented with the variable t, and where we have the 20 minus t is the region 3 or E only, or region M complement intersection E. So when you make this the number of mass the subject here, number of mass will be equal to the number of mass only plus the intersection. So when you add 30 minus t and the intersection t, you will get 30. So to get this only parts, you deduct the intersection from the total number of students who study math, and you get 30 minus t. So that's how we got the 30 minus t here. Also, this intersection t plus the 20 minus t will give you 20. So when you deduct the t or the intersection from the total number of students who study English, you get 20 minus t. So also never forget to write the number of union at the right side, top right corner of the rectangle, and never forget to write the name of the sets like this: number of M and number of E. So always when you are drawing your Venn diagram question, always attach the name of the sets on top of the circles. So let's come to our step 3. The step 3 says sum the information and equate it to the union. So the number of M intersection E complement plus the number of N intersection E plus the number of M complement intersection E equals number of U. So M intersection E complement represents M only. So region M only is this part plus region N number of M intersection E, which is the intersection. So region M only plus the intersection plus the number of M complement intersection E. So M complement intersection E means E only. So region M only plus the intersection plus the region E only or the English only equals the number of U or the total set U. So this is how it will be. So region M only or mathematics only was 30 minus t, and the intersection M intersection E was represented with variable t plus the number of M complement intersection E, which was the English only was also represented by 20 minus t. Then you equate it to the number of the total students in the class, which is 40. So it will be 30 minus t plus 20 minus t equals 40. So 30 minus t plus 20 minus t equals 40. So let's group like terms. So let's bring the variables to the right and the numbers to the left. So it will be 30 plus 20 minus the 40. The 40 cross the equal sign, so it will have a negative or a minus in front of it. So it will be 30 plus 20 minus 40 equals t. So this first t cross, it had a negative sign attached to it. So when it crosses the equal sign, it will be positive. And let's come to the second t. The second t had a positive sign in front of it. So when it crosses the equal sign, it will become negative. And the third t was negative t. So it had a negative sign attached to it. So when it crosses, it will become a positive t. So t minus t plus t will be equal to positive t, because positive t and negative t will cancel out, leaving with this positive t. So it will be 30 plus 20, which is 50, minus 40 equals t. So 50 minus 40 equals 10. So 10 equals t. Therefore, t equals 10. So the number of the intersection, or the mass intersection E, or number of students who read both mathematics and English, equals 10. So that's our first question. Let's come to our question 2. The question 2, I'll let you solve it at your leisure time, then you post it on the comment review of this channel. So in a class of 36 pupils, 19 read biology, 16 read chemistry, and 5 were not allowed to read both subjects. Find the number of students who read I, both biology and chemistry, II, only chemistry. So in a class of 36 pupils, 19 read biology, 16 read chemistry, and 5 were not allowed to read both subjects or any of the subjects. Find the number of students who read I, both biology and chemistry, II, only chemistry. So you use the same approach as we used in solving the first question, but I'll let you solve this on your own, but I'm reviewing it for you. So step 1, write your given information. So you write the given information and underline it, then you summarize all the clues in the question. Step 2, you illustrate the given information on the Venn diagram, but write the title Venn diagram and underline it before you draw. And don't forget to attach the name of the sets on top of the circles. Step 3, you sum the information and equate it to the union or the total. So when you finish, you start with the solving or the questions. But note that you were given region 4, or the number of B in C or complement. So when you read the step 3, your first line for the sub question I, both biology and chemistry, should be this: number of B intersection C complement plus number of B intersection C plus number of B complement intersection C plus number of B union C complement equals number of U. So I'm explaining this. So B intersection C complement means number of B only. So number of biology only plus number of B intersection C, which is the intersection. So both biology and chemistry is the B intersection C. So B only plus the intersection plus number of B complement intersection C. B complement intersection C is C only plus number of B union C or complement. This is the region 4. So the region 4 is the B union C complement. Then you equate it to the U. So it will be B only plus intersection plus the C only plus the region 4 equals U. Because you were given the region 4, that's how your first line should be. So your Venn diagram should be like this. So when you finish solving, then you compare it to this Venn diagram to see if you are correct. So number of B equals 19, number of C equals 16, number of V equals 36. So represent the intersection with any variable. So T, so here will be 19 minus T, which is the biology only. C, here is the 16 minus T, which is the chemistry only. A number of B in your C complement equals 5. This is where you write it. So the region 4, you write is set beneath the circles. So this is how it should be. So solve the remaining sub questions I've given you. So post your answers on the comment page of this channel, but don't forget to like and subscribe. Subscribe for more educative videos. Bye.